Alright, in this video here we're going to do a couple examples where we use the law of sines to solve for sides and angles of triangles. Alright, so if you didn't see the video that I did on the law of sines where I explained what the formula is for and an example of it there, check out that video first before you watch this one so you know what the law of sines is before we actually use it to solve some problems. Alright, so here we're asked to solve this triangle. Right, so we have a triangle where we're given the length of side C is 80.4. We don't know the lengths of sides A and B, but we know two angles. I know angle A is 20 degrees, and I know angle C is 25 degrees. All right, and I'm asked to now solve the triangle. Remember, solving a triangle means finding the measures of all three of the angles and finding the lengths of all three of the sides. All right, so I have to find one angle, angle B, I need to figure out, and then I also have to find the lengths of sides A and B. Well, the first thing I can do, the easiest thing, is to find angle B. Right, if I know two angles of a triangle, the third angle has to be the number that makes all three of them add up to 180. Right? Remember, the three angles of a triangle add up to 180 degrees. So if I add 20 plus 25, right, the two angles that I know, that gives me 45 degrees. And then I do 180 minus 45, and that's going to give me 135 degrees. Right? So angle B is 135 degrees, and that's the first part of solving for this triangle. Now I have all three of the angles. All right, so that wasn't so bad, getting that angle. And now we need to go ahead and solve for our sides. All right, so let me start with side A just because A comes before B. It doesn't really matter at this point which one you solve for first, A or B. All right, so I need to find side A. So the angle opposite A, right, angle A, is 20 degrees. So the law of sines says if I do the sine of angle A, so sine of 20 degrees, over side A, which I don't know, so I just put the lowercase a there, it's equal to, now in this case, I'm not going to use angle B with side B, because I don't know what side B is. I can't do like sine of 135 over B, because then I have two unknowns in my equation, and I can't solve for two unknowns in a single equation. Right? I need to use the side and angles that I know, and I know side C is 80.4, and I know that angle C is 25 degrees. So I'm going to do the sine of 25 degrees over side C, which is 80.4. Right, remember, when you're using the law of sines, you need to, one of your fractions has to be a side and an angle that you know. Right, so in this case, that's side and angle C. Right, I know side C is 80.4. I know angle C is 25. That has to be one of my fractions, and then the other one I can do, for either side A or side B, whichever one I'm trying to solve for. All right, so that's going to be one thing I have to do here, and while I'm at it, I might as well set up the other proportion that I need to solve this. To solve for side B, what I would need to do, well, I would have to do the sine of angle B, right? So it's going to be the sine of 135 degrees over side B, right? So the angle, the sine of the angle over the opposite side is equal to the sine of any other angle over its opposite side. And once again, I need to use the one that I know, which is C, right? So I do the sine of angle C, 25 degrees, over side C, which is 80.4. All right, so that's what the law of sines tells us. It tells us that the sines of the angles are proportional to their opposite sides for all the angles and sides of a triangle. All right, so those are the two equations now that I need to solve, and I'm going to do just one at a time to solve them. But the steps that I'll be taking to solve them will be pretty similar because those two equations look pretty similar to each other. All right, so that's my setup to solve for my two missing sides. Right? Sine of the angle over its opposite side equals the sine of another angle over its opposite side. That's what the law of sines says. And I just set it up for whatever my unknown is goes into one fraction, and whichever one where I know the angle and the side goes into the other fraction. And now it's solving, and if you watch the other video that I did, this is pretty similar to that example. So the first thing I have to do to solve this is cross multiply. Right? The 80.4 comes up over here, so it's going to be 80.4 times sine of 20 degrees equals, and then the A comes over here, A times the sine of 25 degrees. And then to solve for A, right, to get that A by itself, I divide both sides by the sine of 25 degrees. Right, so side A is going to equal whatever all this is, 80.4 times the sine of 20 degrees divided by the sine of 25 degrees. All right, and I just go to my calculator, I double check my mode to make sure I am in degree mode, which I am. So I type it in, 80.4 times the sine of 20, close parentheses, divided by the sine of 25. All right, and when you're doing these law of sines problems to solve for the side of the triangle, it's always the same setup, right? Your unknown is going to be, if you're looking for a side, your unknown is going to be in the denominator, right, here or here. So you cross multiply, you divide this thing to the other side, and then that's what you type in the calculator. And I get 65.066. So let me round that to 65.1. We don't have any units, so it's just 65.1. Right, and I rounded it to 1 decimal place because the side C was rounded to 1 decimal place, or it was given to 1 decimal place, 80.4. So my side A now I know is 65.1. All right, that's the length of side A. All right, so I solve for here. Now I go over here to solve for side B. I go ahead and do the same thing. Now at this point I would have a choice. Now that I know what side A is, I could set this up so that over here, instead of this stuff for side and angle C, I could use, I could use sine of 20 degrees over 65.1. Right? The reason I don't want to do that though is because side A was not exactly 65.1, right? It was 65.066 something, and it was like a long decimal. So this is a rounded off answer. So if I use that number to do my next step in the law of sines, introducing that little bit of error, just that little bit of rounding it off, means that the next answer I get is going to be off a little bit from what it actually should be, right? And it might not be that big of a deal. It might be off by like 1,000th or a 10,000th, like the 3rd or 4th decimal place, but it might introduce enough error that it gives you the wrong answer. So word of advice is, when you have to use the law of sines twice, go back to the original information we were given. This is 80.4. That's exactly what side C is. And I know angle C is exactly 25 degrees. Use that, you're going to get a more accurate result than if you use this rounded off answer from that first step. All right, so just being careful about things like that. Like I said, sometimes it doesn't make a difference. Like your answer will be different, but it might be so far down, like so many decimal places down, that it doesn't make a difference for how you round your answer. But sometimes it does make a difference, right? So you always want to use the most accurate information. Use the information you were given at the beginning of the problem rather than the answers you get from intermediate steps, if you have that option, which here we do. All right, so I want to solve now for side B, right? I already have this set up, my law of sines. So once again, I do the same steps I did over on this side. I cross multiply. I'm going to get 80.4 times the sine of 135 degrees equals B times the sine of 25 degrees, and I divide both sides by the sine of 25 degrees. All right, so side B is going to be 80.4 times the sine of 135 divided by the sine of 25, right? And notice, it's almost the same thing that we had over here for side A. The only difference is here we had a sine of 20 degrees. Here we have sine of 135 because I used a different angle. This is angle B, this one's angle A. The rest of my result looks exactly the same. So 80.4 times sine of 135, close parentheses, divided by sine of 25. All right, so I type that in the calculator like so, hit enter, and I get that side B is 134.5 units. All right, so B is 134.5. All right, and I have now solved this triangle. I got my missing angle, angle B, which was the easiest part, just making sure the angles add up to 180. And then once I get that, I can use the law of sines in order to get my missing sides. Right? Remember, when our angle or when our triangle is not a right triangle, there's no 90-degree angles anywhere in there. I can't use SOHCAHTOA. I can't use the opposite, the hypotenuse, and all that stuff. In order to solve for angles and sides, that only works with right triangles. So if I have a triangle that's not a right triangle, then I use things like the law of sines, like we did here, to solve for my missing sides and my missing angles. All right, I'm going to pause the recording here and do another example. The next one will solve for a missing angle in our triangle, so it'll be a little bit different. All right, in this example, I'm given a triangle, and I'm asked to solve for this angle theta over here. All right, so first off, I notice it's not a right triangle. I only know one angle in here. It's 67 degrees. I cannot assume that any of those other angles are going to be right angles. And so I can't use SOHCAHTOA to figure this out. I can't use this stuff for right triangles. So can I use the law of sines here? The thing to look for to know whether or not you can use the law of sines as opposed to the law of cosines, which is something I'll be covering in another video soon. The law of sines you can use when you know one side and its opposite angle. If I know any one side and its opposite angle, and then any other one bit of information, right? Any other side or any other angle of the triangle, if I know that, I can use the law of sines, right? So do I have that situation here? I do, right? I know this side is 80.2, and I know its opposite angle is 67 degrees. right? So if I know one side and its opposite angle, and then I know one other bit of information, right? This side over here is 56.3, I can use the law of sines, right? Because remember, the law of sines is those proportions. I need to be able to fill in 3 parts of the proportion in order to solve for the 4th part. Well, here I can fill in the sine of 67 degrees, right? I know that angle, over its opposite side, which is 80.2, right? So that one fraction is completely filled in. I need to have that in order to use the law of sines. One fraction where there's no unknowns. That's why I need one side with its opposite angle, because that's going to fill up that first fraction for me. And then that equals, and then the one other bit of information, I know a side over here is 56.3, and then up here is the sine of the angle opposite that side, which is this angle theta that I'm trying to solve for. Right, so that's my setup here with the law of sines when I'm trying to solve for an angle. Right, I know one angle and its opposite side. I know the other side, and I'm looking for the angle opposite this side over here, 56.3. Right, so that's my setup using the law of sines, and now I need to solve for that angle theta. So to get this theta by itself, first thing I'm going to do is get rid of this 56.3. Since it's sine of theta divided by 56.3, I need to multiply that 56.3 to the other side. Right, and when I multiply something times a fraction, it multiplies by the numerator of the fraction, right? If it helps, think of that as 56.3 over 1. The 56.3 is going to multiply the numerator. The 1 is going to multiply the denominator, and the denominator stays the same. Right, so I'm going to end up with 56.3 times the sine of 67 degrees over 80.2 equals the sine of theta. Right, now notice that the last example that I did, when we were solving for one of the sides, I cross-multiplied. Once I had the fraction set up, I cross-multiplied. I'm not going to do that here. Since I'm trying to solve for theta, like I don't want to multiply this 80.2 up to this side, because then I would have an 80.2 times sine of theta, and then to get the theta by itself, I would just have to divide that 80.2 back to this side, so it would amount to multiplying it over and then dividing it back and just ending up with what we have here. Right, so when I'm solving for an angle, I don't actually cross-multiply. I leave this denominator here. I just multiply this denominator up to this other side. Right, it saves me that extra step of multiplying and then dividing it back if I were to actually cross-multiply, like when I'm solving for a side of a triangle. All right, so I get sine of theta equals all this. Now, common mistake people make is to say, okay, sine of theta equals all this. Let me type all this into my calculator, and then that's my answer. Right? That's not what theta is equal to. Right? We're looking for the angle. It's what sine of theta is equal to. So in order to solve for theta itself, I need to cancel out the sine. Right? The sine function. Right? It's the sine of theta. Well, what cancels out the sine function is the inverse sine function. Right? So I do the sine inverse of all this, and I do the sine inverse of all that, and the inverse sine function cancels out the sine function. Right? So I get that theta is going to be equal to the inverse sine of 56.3 times the sine of 67 degrees all over 80.2. Right? If you haven't seen the videos that I did on the inverse trig functions, you should definitely check those out. The key thing is when you're solving for an angle, you have to use the inverse trig function. You don't just type in, sine of all this stuff or just type all this in. You have to do inverse sine of all the stuff that's over here, right? Because the inverse sine is what cancels out that sine function over there. So I'm typing this in and I'm trying to talk while I type it and it's not going so well. Sine inverse of 56.3 times sine of 67, close parentheses, divided by 80.2. Right? And once again, just like for that last example, make sure your calculator is in degree mode as you're doing this. Right? So here's how I have it typed in. Right? So it's the sine inverse of all that stuff I had before, 56.3 times sine of 67 divided by 80.2, right? And then I hit enter and I get 40.25, so let's call that 40.3. So my angle theta is approximately 40.3 degrees. Right, so that's how we can use the law of sines to solve for an angle. Remember, every time you're trying to solve for an angle, the last thing you have to do is the inverse trig function. Right, we do all this stuff, I multiply the 56.3 to the other side, but I still have sine of theta. To cancel out that sine function, I have to use the inverse of it, which is the inverse sine function. Right, so I use the inverse sine function on both sides of the equation, so theta itself is equal to the inverse sine of all the stuff we had here, and then you can type that whole mess of stuff into your calculator and get your solution. Right? So that's how we use the law of sines to solve for an angle.